Hey everyone, so in this video I just want to talk about two operators, two symbols. The first one is the ampersand and the second one is the star. So although you might say that the star stands for multiplication, it actually has another meaning as well. So first of all, what I'm going to do is create a variable n, let's say, and I'll just give it a value 10. And now what I also want, something that's important to me, let's say in some program, is the address of this variable n. So I need the way to create an address variable is to write int star, and for now just accept this star here. I'll tell you what it is. I'll call it ADDR for address, and what it should hold is the address of n. So I just need to do an ampersand n here. So as far as the star is concerned, just apart from declarations, just read a star as at address and read an ampersand as address of. So let's say we print the address here. So this thing that we've actually created when we say int star is it's called a pointer, and to be particular, it is an integer pointer. So for a pointer we use %p here, and I need to give it ADDR, and let's just save this and try running it. So as you can see, I got some value here. It says 0xFFFF So this 0x actually just denotes that this is a hex number, a hexadecimal number. A hexadecimal number is it's based on a system where the counting goes something like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, E, F. So these A, B, C, D, E, F are actually digits in that number system. Just like we have binary with just 0 and 1, we have decimal with 10 digits. So this hexadecimal has 16 digits, and addresses are represented in a hexadecimal format. So this 0x just means that this is a hexadecimal number, and the address is actually FFFFCBF4. So that's the address of this variable n, and let's just try copying this, and let's just do an n++ and print this again. Let's compile this. So alright, I should have a \n here, that would be better. So as you can see, I've got the exact same address. That's because when we do an n++, the value inside the address changes, but the address itself does not change. So now it might make a bit of sense to you why we what this percentage in a scanf means. When we do a %d and then we give it a \n, it just means that, sorry, not a \n, an ampersand n. It just means that whatever value we read, whatever value the user gives, should be stored at this address. So we're just passing the address here. So it's stored at that address. That's what it means, which is why we give an ampersand in a scanf. And when we do a printf, we don't actually do that, because we don't want to print the address, rather we want to print the value. and instead of using an ADDR here, I can actually just use an ampersand n, and it would give me this exact same result. So as you can see, I got the exact same thing. That's because again I'm saying that print address of n, and let's just try doing something else now. Let's change this to d, and let's keep this n, and let's compile now. Obviously we know that we are going to get 10 here, but now let's just try doing star ADDR. And as I told you, you should read a star as at address. So what we are doing here is we are saying print an integer, and what integer is it? It's the integer that's at address ADDR, at address ADDR. That's what it means. So once again we are going to get a 10 here. Let me just clear this, and as you can see I got a 10 again. And let's just try doing an n++, and let's just do this again. So this time what's going to happen is we are going to get a 10 and then an 11, because what happened was first we said print an integer, and what integer is it? It's the integer which is at address ADDR, and then we're actually incrementing the integer at that address. So the value at that address now changed from 10 to 11, and now we're saying again print an integer, and what integer is it? It's the integer that's at address ADDR. So that's what the star and the ampersand mean, and this is something that's not very easy to understand, and it's still very important. And we can actually also have character pointers. We can have char star, CADDR, let's say, things like that. We can have pointers for anything. We can have pointers to floats, and now this may sound confusing, but we can actually even have pointers to pointers. So what this means is that this ADDR is again just a variable, so even that is stored somewhere. So I can even do int star star ADDR, and let's just have this contain this, and let me just do a print of that right here. I'm just going to print ADDR. Let's just go ahead and run this, and it actually prints FFFFCBE8. So that's actually the location that we just got actually contains the address of n. So this is actually pretty confusing, but I think you'll understand this better with time. And another thing that I want to point out here is that we're actually allowed to add addresses. So I can actually do something like ADDR plus 1, and one question that you might have is, why did we have an integer here? Why should addresses have a type? And the reason for that is because an integer in C is 4 bytes, and when we actually add 1 to this address, it actually ends up adding 4. So let me actually just print both of these. So this is what I'm going to do, and let's just take a look at the result. So as you can see, the first one that got printed is FFFFCBF4, and the next one is directly FFFFCBF8, and I just added a 1 here, so why did this 4 become an 8? The reason for that is because integers in C are 4 bytes. So when you're saying plus 1, it just takes it as I need to go to the next integer address. So it's like saying that let's say a house occupies 4 lanes, let's say, and you're saying the address of this house is some XYZ. So when you reach there and someone tells you come 4 houses after that, what you do is you don't go 4 lanes ahead, you actually go 4 houses ahead, which ends up being 16 lanes. So that's kind of how you can look at this. And once again, addition of these pointers is allowed. Subtraction is again allowed because it makes sense, but multiplication and division of these addresses is not allowed. So let me just try doing a multiplication by 2 here. As you can see, I've got an error, and the reason for that is because like I just said, going 4 houses ahead is actually just the address that you're at plus 4. So addition or subtraction would make sense, but multiplication of addresses makes no sense. So you can't multiply pointers. That's one thing that I wanted to point out. I think that's enough, and this might sound really confusing at first. It did to me as well, but as long as you can just remember to read ampersand as address of and the star as at address, you should be fine. Just don't read the star in a declaration as at address. A star in a declaration just means that you're making a pointer of a certain type. So that's it for this video. In the next video, I expect to start functions, which is a very interesting and important topic. So stay tuned for it.